Okay, guys. Today we are going to review the 8th and last domain of CISSP. So, coming to the agenda of today's discussion. So far, we have discussed, and I need to update this slide because I hope that you all must be aware that starting June 1st, the pattern of the exam is changing. There'll be 125 to 175 questions, and I'm not sure if 4 hours will be allocated or not. I've not gone through the official word yet, but the test pattern is going to change, and there'll be still 8 domains, but the number of questions is increased by 25 in the smaller as well as the larger bracket. So basically, initially before it was 100 to 150 questions. Now it will be 125 to 175 questions in 4 hours, approximately 4 hours. I'm not sure about that number, the time. So yeah, so far we have talked about the CIA triad in the first session, RMF, risk management framework. We talked about risk analysis, assessment, risk treatment plan. We discussed all that. We discussed about the documents that we follow, policy, procedures, baselines, and guidelines. And we talked about asset inventorying, classification, categorization, labeling, and marking, etc., etc. We talked briefly about all those things. Then we talked about the people and the canons of ethics. We talked about procedures, baselines, and guidelines, how the interplay of these work. We talked about how to handle the data, archiving requirements, defensible destruction and data protection, etc. We talked about system architectures and we talked about security models like Clark Wilson, Bell LaPadula, and Biba, etc. We talked how one is more inclined towards confidentiality, other is inclined towards integrity, stuff like that. We talked about that. Then we talked about common criteria. We talked about trusted computing base and how it is enforced. We talked about reference monitor and how a security kernel is enforced in an environment. Then we talked about cryptology a little bit, and there we talked about symmetric, asymmetric encryption. We talked about how PKI functions, what is a trusted CA, how chain of trust works, and stuff like that, so on and so forth. Then we talked about incident response procedure. In the last domain, I guess. Yeah, in the last domain, we talked about incident response. We talked about malwares, different types of malwares. Then we talked about viruses, worms, macroviruses, polymorphic viruses, etc., ransomware, etc. We talked about identity access management. We talked about how Kerberos functions. We talked about SAML also. We talked about OpenID, OAuth, etc., etc., etc. Today, we are going to talk about the software development security, and this is the final and 8th domain pertaining to your CISSP test course here. But before that, before jumping to the discussion around software development security, let's address the questions pertaining to the last domain that we discussed. And there you go. The first question is, Jordan is preparing to bring evidence into court after a cybersecurity incident investigation. He is responsible for preparing the physical artifacts, including affected servers and mobile devices. What type of evidence consists entirely of tangible items that may be brought into a court of law? I'll give you 10 seconds. You punch in your options, the options that you think are correct, in the chat window. And after 10 seconds, we'll discuss about it. Cool. So 10 seconds are up. As I can see, some people have said a real evidence, and I think at least one option was there which talked about documentary evidence. So including, okay, so entirety of tangible items is our keyword here. And what includes this is a real evidence. When you capture everything instead of, so entirety of tangible items is the keyword, and with that you can easily deduct that we are talking about a real evidence. Cool. So option D is correct in this case. Let's move on to the next one. That is, Lauren wants to ensure that her users only run software that her organization has approved. What technology should she deploy? Starting now, 10 seconds. So time's up, and I can see there is a divide. So let's talk about blacklisting, whitelisting, and gray listing if there is any. So what blacklisting is, you allow everything and then specify this, and this to not be executed. That is when you're maintaining a blacklist of items which shall not be allowed. What is happening here is that only approved, these are your keywords, only approved software must run. In a blacklist, what we are doing is we are maintaining a list of only the softwares which are not approved. What happens in a whitelist is you specify that software number 1 or thing number 1, item number 2, and item number 3 are the only allowed things in the organization. And that is the case here. Only approved are your keywords, and hence whitelisting is the correct option in this case. Sorry. The third question is, Matt wants to ensure that critical network traffic from systems throughout his company is prioritized over web browsing and social media used at this company. What technology can he use to do this? Time starts now. Your time's up. So everybody here, I think everybody has gotten it right. One person has told VPN, and if you remember the session where we talked about network security, we talked what VPN is. VPN is basically a tunnel which is also encrypted. Okay. So when you make a tunnel between two network devices, which is also encrypted, happen to be encrypted, then it is a VPN. And what we are talking about here is we are talking to prioritize. A VPN doesn't prioritize. VPN ensures confidentiality. It secures. It doesn't prioritize. What prioritizes? Quality of service. So in quality of service, you basically assign some parameters. For example, this much amount of bandwidth shall be reserved for this particular service. Or during this time to this time, this much bandwidth must be reserved for this service. So you can write multiple kind of a combination of and or rules which define the network utilization, network resources which will be allocated to a particular type of traffic. So that is what is happening here. So prioritize is your keyword, and hence QA is your correct option. Moving on to the next set of questions. The fourth one is, which of the following refers to the expected amount of time it will take to get a device fixed and back into production after its failure? The time starts now. Please punch in your answers in chat box. Cool, your time's up. You're supposed to write down your options and not the phrase itself. Okay. Cool. So again, there is a little bit of divide. Question number 3 once again. So just try and understand this. Matt wants to ensure what is happening here is that try to figure out the keywords in any question that you encounter. So what is happening is they're talking about prioritizing the network traffic, critical network traffic. That is that may be a bunch of applications which may be having specific source and destination IP addresses. Okay. So what are your options now? You're prioritizing your critical network traffic, and your options are VLANs. VLANs is meant for segregation. ISDN again is not it's a WAN technology. It's again not in the right context. VPN, I've told you, it is to secure your traffic data in motion. Okay. So what are you left with? Either you can strike out all the options which are not relevant and then reach to your correct option, or since you already know that quality of service deals with prioritization of network traffic, it is the right option. It is a straightforward question. It is not much to think about. ISDN WAN technology. I don't remember the expansion if you want me to expand that. You can easily Google it. So let's move on to the fourth one. So, so what is an MTBF? So most of the people have punched in the options D and B. Let's talk about these two, because hot swap is obviously is not the right thing. Hot swap basically means that you can remove a component and replace it with a similar kind of component, similarly spec'd component, while the system is still running, and it won't affect the system performance. So that is hot swappable. It is not right. SLA is a contractual agreement, so it is also not correct. What is MTBF? Mean time between failures. So that means that every system has a expected life assigned to it. Say when we buy a server or something, a computer or something, we assign a life to it as 5 years. We have done our assessment. There is an industry standard of 3 years of warranty, 2 years of your post warranty service. So we have assigned a 5 year 5 year tenure to as being the life of the system that we are expecting. That is your MTBF. Mean time between failures is the life that you expect for the system to service as expected until it first breaks down. So between breakdowns, the time that you expect the system to perform as expected is MTBF, mean time between failures. And MTTR is mean time to recovery. So what are we? It is either the device is fixed and back into production, and mean time to recovery. Doesn't it sound similar? So that is why the option B is correct. MTBF is basically connected to the perceived life of an or assessed life of an get a device fixed and back into production. We are talking about recovery more than so MTBF is something that is done as a precaution. What we are doing here is a recovery operation which has happened after the fact. MTBF happens before the fact. So MTBF helps you in plan the things out, like how to plan your spares, when shall you replace the system before it breaks down for the first time. For example, I've already done an assessment that a particular model of a server breaks down in typically serves for 5 to 6 years. So I'll plan my entire procurement process accordingly. So maybe if the system is supposed to last by 5 years, I'll start my procurement process on 4.5 years. So maybe by 6 months, I'll be able to onboard the next system to replace the existing system. So that is where MTBF comes into play. When it comes to recovery, recovery is after the fact. Your system is already broken. So that is where MTTR comes in picture. Cool. Let's move to the fifth question, which is RAID systems use. B is the correct option. MTTR is the correct option. So let's move to the fifth question. RAID systems use a number of techniques to provide redundancy and performance. Which of the following activities divides and writes data over several drives? Your time starts now. Okay, the time's up, and people are divided between the two. One is stripping, other is mirroring. Mirroring basically means that you have got A and B, you have got two drives underneath the RAID controller, then both A, B will be written here. It is mirroring, okay? What stripping means is you've got A and B. Now you'll break it down to A1, B1, A2, B2, two parts, or whatever number of strips that you want to make of. Basically, stripping is dividing the data into two or chunks and writing it down in separate drives. So A1, B1 will be written here, A2, B2 will be written here. Stripping basically helps improve the performance because you're taking lesser time to write half the amount of data in any drive, and you're parallelizing the entire process. So you're reading simultaneously, and you're writing also simultaneously. That improves your performance. So that is an example of what we are talking about here is stripping, not mirroring. In mirroring, you get the full data on both the drives. In stripping, you cut it into half and put half of it on one drive, other half on other drive. Okay. That is how stripping works. Cool. Move on to sixth one. Which of the following dictates that all evidence be labeled with information indicating who secured and validated it? Time starts now. Cool. I think everybody has gotten it right. So yeah, option number A is correct. It is chain of custody in which you enumerate all those things. Okay. Now I'll be minimizing the chat section. So please, fourth question again. I am still inclined to MTBF, mean time between failures. Okay, cool. Let's figure it out again. So here there are two parameters. What MTBF means is I have a system which has a particular lifespan attached to it. For example, humans have a life expectancy. Okay. Say you have a life expectancy of 78 years in a developed country, and maybe in a country like India, you have 65 years. So accordingly, you plan your life insurance, you plan your investments, you plan your retirements, etc. Associated to the life expectancy, you have already figured out on a human being. Okay. Similarly, every system has a life expectancy, which is the number, which is the parameter which is mentioned here. It is basically a life expectancy of a system. MTBF is mean time between failure is a life expectancy of a system. What we are talking about here is something is already broken and you're fixing it back into production. So something was already failed. MTBF, by the virtue of its nature, the parameter is it helps you plan your entire life cycle, asset life cycle. Okay. What has happened in this question is something is already broken and now you're fixing it. So that is your mean time to recovery. You're recovering your environment back to the. So remember the DRP that we discussed in the last session. So it is related to that. Your system is already broken. You're trying to fix it and recover it back to the full capacity. Cool. So I'm minimizing the chat section now. So it won't be monitored actively. So let's jump into the domain 8 discussion and pin your doubts, questions, thoughts, whatever, and we'll discuss it after the end of the session. There'll be 10, 20, whatever amount of time that you guys require. It will be available for you to discuss things out. Okay. So moving on to the software security. Software development security. So it is a pretty straightforward domain, I guess. And I think, yeah, it is a pretty straightforward domain. And when it comes to software development security, there are 3 pointers to it. It stresses on development part of it, but we'll talk about SLC and SDLC both. SLC is your system lifecycle, and SDLC is within that. One of the parameters is your SDLC, software development lifecycle. Okay. So what is software development lifecycle? Once you have a why do we need a software? First of all, why do we need a software, or why do we need anything for that matter? We need anything because we have a problem that needed to be solved. Okay. And in case of softwares, we again have a problem statement. That is your basically that is your okay. You have a problem. Oh, sorry. You have a problem and you have a solution to that. That is your software that you're going to write. That solution based on what language you're going to implement, based on what kind of environment you're going to use, and what skills you may be having on board. Maybe you have you have programmers which are not so good on OOP, or maybe they are using some particular language, say C++ instead of Java or Python and whatnot. So based on that, you make certain design choices, and you plan things out based on the resources. Maybe you are running all the operations on-prem, so you plan it accordingly. Maybe you're running all the systems in a cloud-based environment, which is a distributed environment again. So your architecture will look different from what is there in on an on-prem environment. Maybe you're having a vertical scaling requirement or a horizontal scaling requirement. So all these factors come into play in the kind of solution that you'll draft, and your solution is the plan that you draft. Okay, and once you have planned it, what you obtain is you obtain management's consent on it. Okay, so plan plus consent is your first step in SLC, system lifecycle. Then we move to requirement analysis. Once we have a plan in play, we understand what the end user may be wanting from. So you have a solution, the problem that you have envisioned, but it is quite possible that the end user is facing a different kind of challenge similar to what you are facing, but they may be having different expectations from that, from whatever solution that you're pitching. So that is where requirement analysis comes into picture. For example, there is a entity, one org1, and two other entities are merging into this. Okay, org2 and org3. Now what happened is they were having an Active Directory in the environment, and these also were having their own Active Directories. And what this organization, the organization which the other two are merging, does not require to, does not want to continue these Active Directories and want to merge it into a single consolidated Active Directory. Now what they can do is they can create a independent Active Directory in which they move all the user and computer objects as well as their GPUs, group policy objects. And same here and same here. Either it can be done like this, or it can be the same AD which they are using can be used as the base Active Directory. Build a two-way trust relationship between the two, and let the objects from this Active Directory and the other Active Directory move to this Active Directory. So a single problem can have multiple solutions, as we can see here. This is the solution number 1. This is the solution number 2. And it depends on organization's budget, the kind of timelines that you may be having, the kind of skills that we are having to draft a proposal. And that this is where you obtain the consent, and this is also where requirement analysis comes into picture. So you have obtained consent that, okay, AD needs to be merged, but how? That is where requirement analysis comes into picture. It answers the how part. Now you know how, then you draft a design, which generally gets captured into HLD and LLD. What HLD is? HLD basically tells you what are the moving parts in a bird's eye view. It doesn't give you anything in very detailed manner. LLD, on the other hand, is like more like a procedure. So it gives you step by step what kind of changes will be done and how it will be implemented in your environment, and what will be the risk, your risk after or during the implementation of it, because your organization is already having a RMF in place. So based on that, it will also capture the risk involved in the activity and risk after the fact that AD is merged, because federation and all is a risky process. Building a two-way trust relationship between two Active Directories is a risky affair. So this kind of thing will LLD will capture those in detail, and HLD will give you a basic bird's eye view. Okay, so that is your design. Now comes the development part, dev, where the code will actually be written, it will be tested for bugs, it will be compiled and released. So the last phase of this development moves the code to testing and then your deployment. These are very closely related because most of the organizations nowadays follow DevOps, in which these things are automated. So we'll come to that. So basically, you have these steps. You have plan and management consent. You have your requirement analysis. You have your design, then your development, then your testing, deployment, operations, and disposal. Disposal again comes to defensible destruction. Okay, and during the this design and requirement analysis phase, we figure out the kind of data that we'll be capturing and what kind of data will be involved in this, and hence we decide the classification of the proposed system also. So this is where you classify also, and then bake in the security appropriately. So once you have the classification in hand, you can choose, once you have the classification and the risk involved in the whole process in hand, you can choose a kind of security controls that your organization must have already documented in a standard of some sort to implement throughout the process of development, deployment, testing. So this all must be documented over there. So that was your system lifecycle. And anything in system lifecycle which falls between plan and this deployment is your SDLC. Anything which is not within this plan and deployment, that is your operations and disposal, op and disposal. That is in addition to this, and in total, in sum total, it is called SLC, system lifecycle. I hope that is clear so far. Now, secure software development. There are some. I recommend you visit OWASP once. Okay, to understand what kind of common vulnerabilities that are there in the web applications. Yeah, so secure software development. There are few key things that must be kept in mind, and when we talk about securing a software development, the security part of it must be integrated in the entire life cycle and not in just one step. So while you're planning, I've told you, you must be having a framework in place. When you're doing the requirement analysis, you have to have an understanding or a visibility of the impact that of the changes that you're going to put into your environment. Similarly, while designing, deployment, testing, while designing, development, testing, and deployment, you should have security in mind. So what are the key concepts that shall be taken care of is input validation. What input validation means is any kind of function or object which is taking any input from a user, or for that matter, taking any input of any sort, it must validate for example, if there is a integer variable, and if a user is submitting a string, it shall not take that as an input because the data type doesn't match. Okay, so what input validation means basically is whatever kind of data the application, whatever kind of input the application is expecting, it must validate if the input that is actually provided is in line with the kind of input that is expected or not. If the provided input is not in line with the expected input, then it shall decline such requests without executing it. And that saves a lot of effort. For example, SQL injections can be prevented using this if only we validate the input properly. Then you have session management. Session management basically means that, for example, a user is having an active session, authenticated session, and as we have already discussed, it can be a user or an admin privilege that sets the context of user, at what context it is operating, at what privilege level it is the user is operating. So session management deals with say continuous authentication. So what continuous authentication means is once you have authenticated the user, you re-authenticate the user. For you must have encountered session timeouts, idle session timeouts. If you're not providing any inputs, maybe after 10, 15, 20 seconds, you are supposed to log back in. For example, if you use any soft tokens, if you are not using the application for a while, it will automatically lock itself. Or in your mobile phones, once you have entered your PIN, there's a screen timeout. So if you do not provide any input in the screen, it will automatically log the phone back in. So that is the kind of practices that we use for session management. So basically, you re-authenticate, you validate whether the user is the right person. So again, the IEEE of identity access management comes into play here, a part of it. Then comes code obfuscation, which basically means that adding fluff in the code so that if somebody has access to the source code, they may not be able to figure out as to what the code is meant for. And that can be done in multitude of methods. One is lexical, that means basically changing the letters, changing the dictionary words of it, or changing the semantics of it. Okay. Second is your data, and third is your control flow. So data deals with the time with adding maybe extra variables that you have defined which do not do anything. Then control flow is the most difficult one to implement, and it basically adds additional routines which are superfluous in nature, which doesn't serve any specific purpose. So code obfuscation basically is to make it harder for somebody to guess what a particular line of code in a source code is doing. Okay. And I hope that you guys know what is source code and what is object code. So source code is something before compilation. Once you compile it, it becomes object code, and it generally is a one-way thing. Although reverse engineering is possible, but it is generally a one-way thing. Then you have poly-instantiation. It basically means deals with having a single variable take multiple values. Say I have single data field called this user's name. Somebody with user privilege will be allowed to see only the first name. Somebody with the admin privilege will be allowed to see the first name, last name, modify it, or maybe delete it, remove it altogether. So that is what poly-instantiation is. You assign multiple values to a single variable, and different users with different authorization levels are shown different values of it. Okay, that is what poly-instantiation is. Now let's discuss about, we have already discussed the plan and management approval thing. We already done requirement analysis. We already done design. Let's come to the big portion of it, is development. Development is when you actually start writing the code. Okay. And there are certain methods to it. For example, we have waterfall method. What waterfall method talks about is you plan, you do requirement analysis, you plan, you design, you write the code, you test it, you deploy it. Okay. But if you want to, say at this step, the requirement is changed. Now the plan needs to be modified, but in waterfall, you cannot go back. So you'll have to first deploy this version 1 out, and then you can start this process again, and then release the changed version 1.2 or whatever it is there with the changed requirements which were changed here. But unless you complete the entire cycle, you cannot go back to the planning. So that is waterfall. In Agile, what we do is waterfalls in close successions, say 2 weeks or 1 week. And it is same as waterfall, but you're repeating it again in every 2 weeks. So whatever changes that are introduced here can be taken here. And in the next sprint, it is called, in the next sprint, it will be implemented in the code, and the version will change with the changes which were required. That is your Agile methodology. Then we come to DevOps. DevOps basically involves CI/CD, which is continuous integration, continuous development, and deployment. Okay. Sometimes these two steps are merged into one, and sometimes these two steps are separate. What CI/CD basically deals with is automation of most of the procedures which were performed manually before. So what happens in CI/CD? Remember, we were doing this. Design, dev, test, deploy. What DevOps does is design and dev comes to integration. So what basically happens is, say you have a repository of code, and any programmer has written a new line of code, which once committed goes to your repository, actual repository. What happens is a problem of branching. So say there's one masterpiece of code on which these 5 developers are working, and all 5 have made different changes, but none of them has committed it to the actual repository, and hence there are 5 different branches which are having different kind of functionality which were added by these 5 individuals working independently on this piece of original source. What happens in continuous integration is you commit automatically to it, and then the tests are automated. That is your continuous integration part. So you commit automatically and you test out. So your static SAST and DAST, static and dynamic testing, can be performed automatically, and hence the integration part. Now coming to your development. Development is basically changing the release number. So you sync the repo with the production repo and you release it. And when you release it, it is called deployment. Once you sync it with the repo, it is called development. Continuous integration and delivery. Sorry, it is not development, it is delivery. Integration, delivery, and deployment. So in delivery, you basically sync the repo with the production repo. So the version is out. And once you release it in release it to general people or the intended clients, it is deployment. So that is CI/CD, and that is what basically is taken into account in DevOps. So you integrate your operations with your development efforts and automate most of the things. Then testing and certification. Where does testing fit into your entire SDLC is? While you're developing it, you test it. After development, you test it. So that is where you certify the code to be working as expected. And once you deploy it, since there is a life cycle to it and there's a expiry date to the code that you're releasing, so accreditation means that it is a time bound thing. So this parameter is a time bound thing. So management approves that, okay, this version 1.0 will remain there for a defined lifetime. And after that, there is another version will be removed and this will be released. And this accreditation is valid for those 6, 7, 8 months or a year, whatever the timeline is. So that is your certification and accreditation. Certification maps against testing and accreditation maps against deployment phases of SDLC. Now, again, if we go back to testing, we had discussed testing before, in which we talked about unit testing. Say you have multiple components working in an application, you test each components out for basically whatever input you provide and the expected output, if it is working in an expected manner or not. That is unit testing. And then you integrate the entire system and test it out. That is your system testing. Similarly, testing can be manual or automated. And you can, based on runtime, you can either do static testing, which is analyzing the code for any inherent bugs, or dynamic testing, which is while the application is running, you test it out. And fuzz is again, since the programmers are um, expecting the system to some, since the system is expecting some kind of input. In fuzz, you provide random input to it and see if it is behaving or failing securely or not. Then you can have positive and negative testing. That is, you provide intended input and there is an intended positive output. Then you provide it with the input that is not supposed to take, and it either fails or doesn't give appropriate output. That is your negative testing. And then you see misuse testing, which is like fuzz only, but in which you try to provide as many as malicious or misuse cases. You define the possible misuses that can be done to your system, and then you test it out for that. Then you have operational testing, maybe real user monitoring, where you monitor the data input or interaction with your system done by the real user itself. Or you can provide synthetic input. So maybe running a script, which is a routine, which constantly checks the system for multiple conditions. So synthetic testing is faster. It provides a wider kind of input range to your system. And real user, basically, sometimes we cannot think of the way users can interact. So real user monitoring is also important, but it provides you limited data set, and it is generally slower because you're depending upon the users to interact with your system in order to test it out. So those are your testing methodologies which we have already discussed before. Then you have your regression testing. So every time there is a version upgrade, you test out the functionality before integrating it in the production environment, so that everything works as expected and nothing goes haywire on the D-Day. Then you have maturity models to see how mature the system is, your environment is. Starting with ad hoc, that means nothing is documented, nobody knows what to do, and everybody is doing it on a very casual approach, or maybe say you do not have a risk management framework in place. So while designing, nobody knows what kind of a risk that company is willing to take. What is the risk appetite of the company? What are the controls that shall be, say you do not have an ICMS and ISMS in place. You do not know what controls to put in case of a vulnerability which is there in your system inherently. So those are the things, when documented, help standardize the whole thing. So that is where your policies, frameworks, etc. comes into play. Policies, standards, frameworks, baselines, etc. comes into play. Repeatable is, you have done it once and it is known to be working effectively, so you can do it again. Defined is a well-documented environment. Managed is when you have well-documented environment on top of metrics to assess the effectiveness of the controls that you put. So that is when it becomes managed. And optimizes based on the metric, the feedback that you are receiving, you further cut down on the metrics or further make it more efficient, the metrics more efficient, and hence improving the efficiency of overall system. So those are the maturity models. I think in the first session itself, I've asked you guys to please remember CMMI, capability maturity model integration, which was developed by Carnegie Mellon University's SAI Institute, and which is very important from exams perspective. So please remember this, okay? Then we have APIs. APIs you can understand like a door. So you have one system, you have another system. They need to interact with each other. They'll go through APIs. Now, APIs can be of two types. One is REST, other is SOAP. REST is representational state transfer. That basically is a more restricted way of implementing APIs. So the system here already knows what kind of input it shall expect, and it gives point-in-time data in return. So that is your state transfer. So whatever object that this source was trying to, okay, in APIs, generally APIs have this kind of an architecture. You have a client, you have a a resource which is hosted on a server. This is your resource and this is your server. Okay, so the client goes through this gateway to access this resource and the server serves back the request. So this is typically how APIs are structured. And yeah, RESTful representational state transfer is where you give the input and the point in time data is returned. It is very well defined. It is also very secure by that matter only because it is very well defined and it works in an expected manner mostly. RESTful and since these are standardized, so yeah, obviously more secure. Then you have SOAP, another method of implementing APIs, which is Simple Object Access Protocol, which is based on XML and which is more customizable just because of the virtue of using XML, where you can customize your customize the kind of transaction you're having to and fro. And using this, clients can create, retrieve or update or delete records. For example, if you have, for example, say you have a, what is an example of it? Yeah. So during the COVID, this thing, vaccination drive, you remember there was a COVID, this COVID website, which offered an API with which you can retrieve based on the PIN code, retrieve the data like PIN code of the vaccination center, the name of the vaccination center, the kind of vaccine that they are providing, either, I don't remember the name actually. So there were 2 vaccines. It could have, so this kind of information that you could have retrieved from COVID application, COVID website using the API that they offered. So that was a implementation, RESTful implementation, I guess, because you were getting a point in time data and the requests were well defined and structured. So that is the kind of use of APIs to interact with a system in a very structured manner. Okay, then coming to software acquisition. So sometimes, not all the times, people can develop their own software, so they acquire software. What happens in acquiring software? There is a residual, there is a inherent risk in this practice is that what happens if the software manufacturer or the OSD, original software developer, goes out of business. Say you have us again. Remember, we always assess the life cycle, and hence we accordingly we always assess the expected life out of a system, and accordingly plan our procurement and etc. around it. So say we have bought a software for 6 years, and 2 years after the beginning of the contract, the OSD goes out of business. Sorry guys, just give me a second. So 2 years after acquiring the software, the OSD goes out of business, and now you're left with nothing. There'll be no software updates. So any vulnerabilities which are found in the application, which you'll not be able to patch it because you do not have access to source code. So what is an escrow agreement? There is a third party involved. This is you. There is the OSD. There is the third party. Okay. They take the responsibility that, okay, if OSD goes out of the business after 2 years, we'll maintain the code for you, the source code for you, and hence they have a copy of source code, and they do not disclose it to you. Obviously, they do not share the source code with you unless and they only come into picture once the OSD goes out of business. They fail to deliver upon the contract. Okay, so what is a contract? Contract is basically an agreement between 2 parties. What is an SLA? SLA is service level agreement. What is service level agreement is? We obviously, as the name states, you define the level of service expected. For example, you define the RTO, RPO requirements, you define your penalties here, you define all your commercials, how the services will be delivered, cloud, on-prem, how the licenses will be delivered, what kind of support will be there, whether it will be a premium support, whether it will be a common general support, whether there will be a dedicated service manager, etc., so on and so forth, depending upon the cost on hand, depending upon the kind of money that the organization is willing to put, depending upon the criticality of that particular software. So that is your contracts, SLA and escrow. Then you have common software vulnerabilities, which I again will urge you to go to OWASP website once to know more about these actually. So you should go there once at least. Okay. So the common software vulnerabilities are buffer overflow. For example, you have defined a variable which is having a length of 8 characters. Now as soon as your program executes, this 8-character word length will be assigned, a memory of that size will be assigned for your application for that particular variable. Now there is somebody, malicious actor, threat actor, who sends a 12-character word and you doesn't do input validation. So the other 4 characters, which the memory address of this, which may be assigned to somebody else, will now be overwritten by this input that you receive. Okay. And this 4 character, since this belongs to some other application which is running in another user context, it may be a admin privileged application and has privilege escalation can also happen in this case, or at least at the minimum data corruption is happening, because these additional 4 characters are replacing the 4 characters that the other application was expecting. So that is your buffer overflow. So you can prevent it using bound check. Okay, so whenever you're taking an input, you can see what is the length defined and whether you're getting an input which is longer than that. Then you have SQL injections. We have discussed this before. SQL injection, we didn't discuss it before. And there is also one more thing that I wanted to discuss, which is called directory traversal. So, and we'll talk about directory traversal in one of the questions we have. I have placed a question in the upcoming slides. So wait for that. Directory traversal we'll discuss over there. So what SQL injection is basically, when you're receiving an HTTP request, your application, the web application, is expecting it in a certain format. But what if you input a SQL query in that? And if the web application is not doing input validation, it will pass on the query as is to the database, and that particular thing will be queried, and the response will be sent back to the user. So that is SQL injection, where which basically is happening because input validation is not in place. You are supposed to get only HTTP requests, but in HTTP requests, if you're getting SQL queries also, and passed on to those queries are passed on straight to the database, which is behind your web and app layer. So that is problematic. That is your SQL injection. Then you have cross-site scripting. I think that we have discussed before. Cross-site scripting can be of 2 types. One is reflected, other is stored. Reflected is not persistent, stored is persistent. So say you have a website in which you have user-generated content. You can it offers user-generated content, which means that user can post their content on this website, and a user posts something malicious here. Now it will be permanently embedded in this web page. For example, if say it's a Facebook comment section, and there you have posted a script, malicious script, it will be stored forever in this page. And every time this page will be loaded, this script inadvertently will be loaded in the browser and be executed by the browser, because browser will not check whether it shall be executed or not. It will simply render whatever is delivered by the web application to it. So that is your stored cross-site scripting. Reflected cross-site scripting is when you get a malicious URL, maybe in your email, phishing attempts, any kind of social engineering. You send it, you click on the URL, it goes to the web server, and web server doesn't do input validation or doesn't strip off the malicious code, and it comes back to your browser and executed as is. So as you can see here, your browser is the thing which is getting attacked. So cross-site scripting is attacking your browser. Cross-site request forgery is, on the other hand, attacks your application itself, the web application itself. So this is happening on server, this is happening on client machine. Okay, client machine, browser. This is happening on server, which is hosting a application server. Okay. Cross-site request forgery, basically, you steal one authenticated session, and without user knowing it, do some make some malicious request on user's behalf. Say you have a authenticated session of Facebook, and there's a malicious code which executes when you visit a website. There is a drive-by download which downloads a script on your PC, or maybe maybe there is a malicious script on the web page itself, and it executes and it takes your authentication cookie, authenticates itself with Facebook as you, and makes a post on your behalf. So that is the kind of thing cross-site request forgery is. Now you can have covert channels. Covert channels are basically like backdoors. So which are where you infiltrate the information, not directly but indirectly. For example, you can have covert channels on memory and storage. So what happens is you turn the storage bit you mark one sector of your hard disk as bad sector, which will be not scanned by your malware anti-malware scanner because it is a bad sector already. And then you put the bit as 1. Maybe you are talking Morse code, so 1010, you keep on changing it, and eventually you're leaking the data in Morse code. So that is the kind of example of a covert channel. Now you have memory and object reuse. Okay. Okay. Then you have TalkTow, which is time of check, time of use. That basically is a problem of session management. That is, when you check the when you authenticated the user, and when the user actually performed some action, there was some time in between, and there was something malicious happened during this period. So that is your TalkTow. Time of check is your authentication part. Time of use is your action part. In between that, if there is something malicious happening, that is a TalkTow kind of vulnerability. Then coming to DB databases. Databases can be of two types. One is relational, one is NoSQL type databases. So relational databases are tightly related to SQL. Relational type of databases generally have a set schema. Changing a schema may require some downtime, and hence these are very rigid in nature. But since these are rigid and data types are schema and data types are very well defined, these are high performant as well, and generally are used for transactional purposes. What transactional is, basically you frame a request and it is committed on the database. That is one transaction. So you can have two types of databases, SQL and NoSQL databases. As I've told you before, SQL is structured query language, and it is used to interact with RDB, relational databases. What is a relational database? In relational databases, you have multiple tables. Okay, every row is called a tuple, and every column is called an attribute. Okay, then this can be your primary key. Say this is a table containing the usernames and their departments, and this is a table containing the usernames again and the salaries of everybody. Okay, now I want an output stating that this user is having this department and is drawing this much salary. I'll run a join SQL query using this principal key, which is a foreign key in this table. So basically, principal key is foreign key in the other table. And principal key, basically, if you've done VLOOKUP on Excel, or as I've already told you that this is a common attribute. This column is common across both the tables. So the username is common across both the tables, and then hence the username for one record becomes principal key in the first table. And when the same record is there in the secondary table, that is called a foreign key. And that is used, these keys are used to establish a relationship. If you have done a VLOOKUP, you must be understanding what I'm saying, or if you may have run a SQL query, you are understanding what I'm saying. So principal and foreign keys are the unique values which are used to establish a relationship between the two. These will be the common values which will be used to fetch the other attributes in that table pertaining to that common value. So the username and department comes from here, salaries come from here. That is what a relational database typically looks like. Now, ACID properties are related to relational databases, not so much to the non-SQL databases, NoSQL databases. So ACID property, what does it say? It says atomicity. That means whenever you commit to the database, everything will be written on database or nothing will be written. So either everything or nothing. That is atomicity, all or nothing. Then you have consistency, C for atomicity, consistency. Then you have isolation, and D for durability. So isolation, consistency is once you write it, every user who is accessing this must see the same result. Okay. So for example, there's a database of user, again user, and their departments. So no matter who accesses this information, they must be shown Chandresh working in IT department. Okay, always. So that is your consistency. What isolation is? Isolation basically means that unless the transaction is committed, it must not be visible to any other user. So say I'm changing the department of Chandresh from IT to say HR. It will not be made visible to all the rest of the people unless it is committed in database. And once it is committed to database, due to consistency, it will be shown as HR to everybody now. What is durability? Durability basically means that once you have written a change, once you have committed something, it shall remain there and must not be lost or modified. So those are ACID property of a relational database or a SQL based database. Now, what is NoSQL? NoSQL basically means basically expands to not only SQL. Okay. So as we have seen in SQL, there can be tables only. Okay, in these kind of databases, but eventually when big data and all the multitude of data types and the as I've told you that there is rigidity to the schema of the relational databases. So most of the applications which require changing the schema too frequently, and it is again the problem like we encountered it in waterfall. It was too rigid. So we moved to Agile and then eventually to DevOps. Similarly, SQL was too rigid and too well defined in the beginning. You're supposed to define everything in the beginning, and changing changing anything in the schema requires you to take the database down and then modify it and take it back up. And also there's a problem with SQL that it is not horizontally scalable, not much. So in the cloud-like environment where everything is distributed across geographies, across systems, you require something which is horizontally scalable, and that is where NoSQL came into picture. So CAP theorem is something which is related to NoSQL. And what does CAP mean is, CAP again is for consistency, C is consistency, A is availability, and P is your partition tolerance. And as you'll see here, consistency basically means that, and since we are talking about distributed systems, so there may be one database which is master and other are slave replicas. What consistency means is, once I make a change in uh, this once any change is made in the database, it shall be immediately replicated to all the instances, so that whoever accesses that information gets the same result out of whatever node that they get the request. So this is my node 1, this is my node 2, this is my node 3. Say node 1 is master, I've made a change in master, and some user request comes in node 3. Say there was Chandresh again, whose department was IT, which was later changed to HR in the master, but it's not yet replicated in the other two instances. And when a user kind of probes in which department Chandresh is working, they'll still get the old result. So that shall not happen in a consistent database. So consistency means that it shall be replicated immediately or with minimum time lag. Then comes your availability. Availability basically means that any request must get a valid response, and that's it. So, for example, it is a cluster of databases, and one of my node is down. This is down, and user request is landing on this. It shall automatically move it to this and cater to the request instead of giving it a failed result to the user. And the final bit is partition tolerance. So what partition tolerance means is, these nodes which are forming my database cluster can be running in geographically isolated locations. So if there is a network outage between the two nodes, it must be tolerated well, and the incoming requests must be handled by the remaining nodes. So that is your partition tolerance, and it may not result in corruption of data. So again, consistency is there. What CAP theorem says is, you can have either two of the three at the same time in a NoSQL database. So there are databases which are CP or AP. And why is that? Why not a CA? Because we are talking about distributed systems, and in a distributed system, partition will always be there. Partition tolerance will always be required. It is not that we do not have any CA system. That is the system which ensures confidential consistency and availability, but it is very rare to find in a NoSQL database. So generally we have CP and AP database. For example, MongoDB is an example of CP database, which CP NoSQL database, which ensures consistency and partition tolerance. Similarly, Apache's Cassandra is an AP database, which focuses more on availability and partition tolerance. Okay. So I think so guys, that is it from my side. Now we'll move on to the questions pertaining to this domain. And after that, we'll discuss your doubts, your queries, your questions that you might have pinned. So again, I'll read out the question for you. You'll have 10 seconds to punch in your options in the chat box. And we'll talk about it in a bit. Okay. Which of the following anti-malware detection methods is the most recent to the industry and monitors suspicious code as it executes within the operating system? Time starts now. Please punch in your options now. Time's up. So most of yeah, A and D. That's a safe bet. Who is that, Venkat? Very smart man. You seriously rock. That is a attitude that we require. Okay. So obviously it's not heuristic detection. Fingerprint and signature are kind of the same, and it anyways doesn't need to. It anyways doesn't monitor suspicious code as it executes. So that is the important bit. That is the keyword here. as it executes on memory basis. And heuristic is kind of a pattern analysis, but the latest one is UEBA, that is user behavior analysis, which is the latest technology in action. It basically also tracks how a user generally interacts with an application and forms a baseline. And if there is anything which is not complying to the baseline, it triggers an incident or event. Okay, behavior and heuristic. Heuristic, basically, you can say that it is a little bit advanced than signature-based detection, but not as good as behavioral detection. What happens in behavioral detection is, first you run the system in analysis mode, where it forms a baseline of the user behavior, and then you run it in enforcement mode. Okay, so behavioral blocking can be customized to specific user or specific organization because it can form a baseline on its own. And heuristic detection is kind of a more aimed towards a fileless threat. So where there is no file which is executing, which is getting executed and hence triggering a malicious activity. Heuristic detection is done for pattern recognition there. And behavior blocking forms a baseline based on the interaction that the user must be having with the system. And that is the kind of thing that we are talking about here. Can anyone give some example of behavior-based blocking in vendors who offer this service? I'm not sure who offers this service, but can we discuss that afterwards, Venkat? Please give me a second. You can look into Carbon Black, actually, VMware Carbon Black suite. They offer something like that. And the second question is, Widgets Inc. Widget Inc.'s software development process are documented, and the organization is capable of producing its own standards of software processes. Which of the following capability maturity model integration levels best describes Widgets Inc.? Time starts now. And your time's up. Okay, so again, there is a divide in the options. What is happening here is are documented and can produce its own standard. What is documented? Defined. Okay. Initially, obviously, is your ad hoc. Defined is defined. Repeatable is the second step. So it is initial, then repeatable, then defined, then managed, and then optimized. So those are your 5 levels. Now coming to the third question. Bryn believes that a system in her organization may have been compromised by a macro virus. Which of the following files is most likely to be the culprit? The time starts now. And your time is up. I've got only one. Okay, there's again a divide. Since it is a macro virus, and I think the first option, the first answer that was submitted was correct one. Option A is correct because macro viruses are generally associated with the Office suite. These are generally designed in VB. These are generally VB scripts, which are attached to Microsoft Office documents, Excel, PowerPoint document. And as soon as you execute it, it runs in the same context as the Office product that you're running. So if you run Office product as admin, it will be running as admin. The code will be running as admin. Okay, moving on to the next questions. Command-line.exe is nothing, bro. It is your CMD utility. It is this. It is This is your command line.exe. Command line.exe can be leveraged in running a fileless malware. Maybe you can run batch scripts. Okay. Carry is analyzing the application logs from a web-based application and comes across the following string. A string that is dot dot slash dot dot slash and a sequence of that, then etc slash password. What type of attack was likely attempted against Carrie's application? Oh my god, people are smart. The time starts now. And your time is up. So yeah, remember I talked about directory traversal while I was talking about the common vulnerabilities in softwares. That is, this question pertains to that only. So coming back to the command line, if I do this cd dot, okay, yeah, in command line it is cd dot, which takes me one directory back, and eventually if I do it enough times, I'll jump to my C root. This is my C root. Now I can simply enumerate the directories which are there and simply do cd to go to whatever directory I want to go. For example, if I want to go to users, I can go there. Or if I want to go to users, then something else, then I can simply write this and go to that particular directory. Okay. So I'm here inside my this directory. So what is happening here is, in Linux, instead of cd dot dot, you do dot dot, and what is happening here is you are doing it enough times to go to your root, and from root go to etc and password where your passwords are stored. So this is an example of directory traversal. You're basically going across different directories. So your application may be hosted in etc httpd or some other folder, some Apache folder where Tomcat service is running or whatnot. But what happens in a directory traversal, you do dot dot enough times, you go to your root, and from root you go to etc and password, and from there you can enumerate the contents of password using ls or maybe cat or something. Okay. Now coming to the fifth question. What term is used to describe the level of confidence that software is free from vulnerabilities, either intentionally designed into the software or accidentally inserted at any time during the lifecycle, and that the software functions in the intended manner? The time starts now. And the time is up. Cool. You're confused between this. Let me go back there. Confused between A and D. We'll go with D. Cool. Good one. Good one. You've got the right. You've got it right. So yeah, cool. What validation was? We discussed it before. Remember in verification and validation? So in verification, if we have documented something in HLD, in verification, we used to check whether it is implemented as documented. And in validation, we used to check whether it is serving the same business purpose as intended. So validation is checking whether the software or whether the system is supporting the business function which it was intended for. Okay. This is a question of assurance, that you're assured of that piece of software being free of all the malicious code which may have been inserted in any point in the entire SDLC. Cool. So with this, I'll tell you, I can tell you guys that we have successfully concluded all the 8 domains. We have successfully concluded the discussion around all the 8 domains of CISSP. If you have been with me since the beginning of it. Okay. and I'm dropping the link for feedback in the chat section. So there you go. Now you guys can unmute yourself. Can you explain verification validation? 1 second. Okay.
Yeah, hi Chandresh,
Now
how
you
are you?
guys can unmute yourself and we can discuss whatever your doubts are.
Hi
So
Chandresh, this slide, how are you?
hi, I'm good. I'm good.
Thank you. First of all, a great thanks for all the sessions from domain 1 to domain 8. I have two queries. One is
Yeah.
what is memory object reuse? And second is I always confuse into identify the keyword while, identifying a stage of CMI model. Like what is defined, repeatable. If you have any keyword terminology to identify the question, that would be great.
I've gotten the first question, so let us figure out that first, and I'll I'll
Yeah.
I'll ask you to repeat it again, the second one, after we are finished discussing memory or object reuse. So what memory and object you reuse basically means is, say you have one application which is using one memory location or one object which is already parameterized by that application. So this is my app one. Now, if the system allows the app 2 to use the same memory address or the same object which was already parameterized by application 1, then I'm introducing data leakage. This app 2 can read the data of app 1 because it is using the same shared resource, memory or object. Okay.
Mhm.
And what was the second one?
Second one is like I always confused when to identify the keyword when a question asked on CMI model steps. What is initial, repeatable, defined, managed?
Okay, 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 cool.
I want to know the keyword if you can help. It would be helpful.
I do not have a semantic for that, but we can
Maybe you
simply,
can, yeah,
I can list it out for you.
yeah. Thank you.
So this is your, let me go back to this section. I might have explained it here. Where is your, okay, where is your CMI? Yeah, it is listed here itself. In ad hoc, it can also be initial. So basically there's nothing documented so far. And every team who wants to implement any kind of security controls, any kind of risk assessment, they'll have to take their own approach. So there's no standardized risk management framework which is running through all the organization. There's no data classification standard which is running through all the applications in the entire, which is unique for the entire organization, which all the moving parts of the organizations follow. So in ad hoc or initial, you basically have not documented any procedures, and you're basically any team, for example, your IT team is onboarding an application. They do not know what kind of a risk appetite do the organization have, or what kind of controls shall the organization put to bring down the inherent risk in any solution that they're onboarding to the risk appetite of the organization. Again, you do not have the classification standard in place, so you do not know what kind of a system, if it deals with PII, shall be secret, in internal, public, or what. So there's no standard document for any of the teams to guide, to get guidance from, in order to make a decision based on the kind of controls that they shall put, or the kind of risk that it introduces in the environment, or the data handling requirements of that solution. Okay, that is your initial or ad hoc. Then in repeatable, you have done it once, then the team itself forms its own guidelines. Okay, because you have done it once and it was working fine for you, so you draft your own data classification standard, you draft your own uh, risk management framework, but it is not still organization wide. Okay, in defined, you have a organization wide standard, and maybe preferably in place of a, in form of a policy. There'll be a policy, there'll be some standards that you'll define, or maybe baselines, and there'll be a framework which will be mapping everything with the moving parts of the organization, or the organizational hierarchy. For example, these are my, here in the framework you'll define the rules. So you'll define, till my manager one, all are data owners. Till my manager manager 2 and 3 are system owners or they business owners. So they approve the controls that the M1 is going to put, and then you have executors, which are your data custodians, which will actually implement the controls. Okay, so that is where framework comes into picture. So that is the defined step, where you define the policy, you define the standards, you formulate a baseline, and then you figure out a framework which will map everything with your organization structure. Okay, then manage this when you introduce metric to it. So you have uh, defined your RMF, you have defined your classification strategy, you have defined your ISMS efforts, what kind of controls shall be put. Now, how to assess whether the controls you have put are sufficient to keep the risk within the within that which is identified as in risk management framework. So you introduce some metrics, KPIs and KRIs, okay, that we have talked about before. So that is where you introduce your metrics.